Hey guys, welcome to another video. Starting with the last video, I want to remind you that the relationship between pressure, density, and temperature is this formula here. So it's pressure divided by density into temperature, which will equal to constant. So I'll put the link of the video in which I've spoken about the universal gas law so that you can have a look and recap. I already told you that if I bring density up here, we get this. Density is directly proportional to pressure and density is inversely proportional to temperature. Now, why am I saying this? The reason behind this is I want to establish a relationship. It's not that I want to, but there is a relationship between density and pressure, density and temperature, and density and relative humidity as well, and density and altitude. These are the four relationships that we are going to establish today. Starting with density and pressure. We already spoke about what is density. We already know what is density. Density is mass per unit volume. So let me draw a box again. So there's an imaginary box, all right, and there is molecules of air in it, right? So what happens when I apply pressure? When I apply pressure, all this gets compressed, right? As this gets compressed, let's say I compress it and bring it to half of this. So the same amount of molecules of air which was there in the full box before is now in the half box, right? Which means mass per unit volume is increased, which also means density is increased. So basically, as pressure increases, density increases. Now let's also use the universal gas law, which says that density is directly proportional to pressure, right? Now, back in school, you remember what is cross multiplication and stuff like that. So if I multiply pressure by 2, all right, so I will also have to multiply density by 2, which means if pressure is increased 2 times, then density will also increase 2 times, right? So if pressure increases, density will also increase, right? That's the number one concept that I want to make you understand. Now let's talk about temperature. Now, what happens when I heat a molecule of air? When I heat a molecule of air, it gets excited, there is energy, and it moves around, right? So let's again take 2 boxes, right? And now let's have 5 molecules of air in both. And these are imaginary units of space in which there are 5 molecules of air, right? In one of the molecules, in one of the boxes, I start heating this up, right? So when I start heating this up, this gets excited and starts moving far away. And hence, there won't be much molecules in this unit volume, because of which the density will decrease as the temperature will increase. But as this is cooled down, what happens is it stays in one place. It does not move around much. It even in fact moves closer. It's a different theory altogether, but it is much closer as compared to when temperature is higher, when temperature is cooler. So finally, we'll get back to our universal gas law, which states that density is inversely proportional to temperature, right? So what happens is, as temperature increases, density will decrease, right? Again, I explained, that's because of molecules moving far away and all these things. You can go back in the video and understand again. So Again, as temperature increases, density decreases. And before this, as pressure increases, density increases, right? So the effect of temperature is opposite as compared to the effect of pressure on density, right? We'll recap all of this in the end. Now I want to get into something called as relative humidity. Now relative humidity is basically what it is. It is the amount of water vapor that is present in the air. In layman terms, you don't have to go into the definition of it. In layman terms, it is the amount of water vapor that is present in the air, right? So let me show you one thing, right? If I take a box and fill it up with 3 water molecules and 3, let's say, any gas molecules, it can be oxygen, hydrogen, and or let's say it's dry air, it's just dry air, and this is just water. Now there is this number that I saw which is very interesting. So in sea level condition, water vapor is the weight or the density of water vapor is 0.760 kg per meter cube, right? 0.760 kg per meter cube. And the weight of dry air is, let me see, yeah, it is 1.225 kg per meter cube, right? Of course, I do not remember the numbers, but these are the numbers, right? So you can directly see that dry air is heavier than water vapor, right? So that means if you weigh these 3 molecules of water vapor with perfectly dry air at sea level, dry air will weigh more, which means the density of dry air is more. Even you can even see these numbers. So the density of dry air is more than the density of air which has a lot of water vapor in it, right? So as relative humidity increases, the density decreases, right? There's a statement that I want to read to you, that water vapor weighs 5/8 as much as dry air, which means that water vapor is lighter than dry air, right? So that also means that water vapor is less dense than dry air. So as the relative humidity or humidity increases, density decreases, right? So again, we'll recap again. As pressure increases, density increases. As temperature increases, density decreases. As relative humidity or humidity increases, density decreases, right? Now the fourth thing that I want you to remember is with altitude. So as altitude increases, we know that temperature and pressure both decrease, right? Now, but I told you that, with a decrease in temperature, density increases, right? But over here, pressure, the effect of pressure is more, dominant in this particular case. So as altitude increases, density of air decreases. And also there's the effect of gravity, right? So gravity is pulling all the air molecules towards the center of the earth, towards the earth basically. So as we move away from the earth, the effect of gravity decreases and the air molecules keep spreading out and the density keeps decreasing. I'll just draw a small diagram to show you. So if you look at this is the earth, right? This is the earth and this is all the atmosphere around it, right? As we keep going away from the surface of the earth, there is less and less air. We know that, right? So as there is less and less air, which means that it is getting less and less denser, which means as altitude increases, density decreases, right? So 4 things that we learned today. One is, this is all you need to remember. Just if you didn't understand, of course you can understand or you can text me, but otherwise these are the 4 things you should take out of this. As pressure increases, density increases. As temperature increases, density decreases, right? As relative humidity increases, density decreases. And as altitude increases, density decreases, right? So that's what you should take out of today. That's it for today. Happy landings, guys. Cheers.